Hello students, I'm Dr. Navneet Kaur from Department of Computer Science and Engineering, Sagar Institute of Research and Technology College. Today I'll be taking lecture on subject digital systems. The topic which I'll discuss here is multiplexer and demultiplexer. Now first I'll explain multiplexer. The term multiplexing means many into one. So multiplexing is the process of transmitting a large number of information over a single line. In digital circuits, a digital multiplexer is a combinational circuit that selects one information from several sources and transmits the selected information over a single output line. So here the multiplexer has several data input lines and the data is selected from these input lines and are transmitted on a single output line. The selection lines are used to determine which input will be connected to the output. So a multiplexer is also called a data selector. This is a basic block diagram of the multiplexer. Here we can see that we have 4 inputs here on the multiplexer and single output is connected. Here we have 2 selection lines. Selection lines are actually decided on the basis of the number of the inputs. The number of the inputs are 2 raised to power n, where n is the number of the selection line. So here we can see that there are 4 inputs. That means 2 raised to power 2. So 2 will be the selection lines because here 2 raised to power 2 is in the form of a 2 raised to power n, where the value of n is 2. So here we will have 2 selection lines. Now here we can see a basic block diagram of 4 to 1 multiplexer. Here 4 inputs D0, D1, D2, D3 are given. One data output line Y is connected and 2 selection lines S1 and S0 are there to decide which input will be connected to the output. Now, this is the logic circuit diagram of the 4 to 1 multiplexer. Here, 4 inputs are connected as I have already discussed in my block diagram and 2 selection lines are there. And there will be 4 AND gates and the output of these AND gates will be connected to a single OR gate and the output of the OR gate will give the output of the multiplexer. Now, if the 2 selection lines S1 and S0 are 0, 0, then I0 will be connected. So, the first AND gate will have inputs I0. Since S1 and S0 are both 0, so S1 and S0 will be given to the inverter and the output of inverters will be given to the first AND gate input. Now, for second combination of S1, S0, which is 0, 1, second output input I1 will be selected. Now here we can see that for second AND gate, the input is I1 and since S1 is 0 and S0 is 1, so S1 will be connected with inverter and S0 will be connected directly to the AND gate. So here we will have S1 bar and S0. Now for third AND gate, we have third combination of S1, S0. So S1 is 1, S0 is 0. So S1 will be directly connected to the AND gate, whereas S0 will be given to the inverter and after that it will be given to the third AND gate input. So for fourth combination, when both the selection lines are 1, the fourth input will be selected and will be given to the outer OR gate. So here we will have the output of the multiplexer, which is F. Now, if any of the 4 combinations of S1 and S0 is selected, say, if I'll say I have combination of 0, 1 as S1, S0, In that case, only the output of the second AND gate will be defined, whereas other AND gates output will be 0. So this output, which will be I1, will be given to the OR gate, whereas the other three inputs of the OR gate will be 0 and the output F will be I1. So in this way, we will be taking a second input which will be connected to the output of the multiplexer. Now, this is a logic circuit diagram of 8:1 multiplexer. That means we have 8 input lines and 1 output. So here we can see we have 8 inputs connected, D0, D1 to D7. Now, since 8 inputs means 2 raised to power 3. So here the value of n is 3. So we will have 3 selection lines, say A, B, C, or we can name them as S2, S1 and S0. Now we have 8 AND gates. At a time, only one AND gate will give non-zero output, and the OR gate will select that output and will give as the output of the multiplexer. Now, coming to demultiplexer, demultiplexer is the reverse of the multiplexer. It is a device with one input and multiple output lines. It is again a combinational logic circuit. Demultiplexer is the process of taking information from one input and transmitting this information over one of several outputs. It is used to send a signal to one of the many devices. Now, this is the block diagram of the demultiplexer. Here we can see we have single input, whereas we have 4 outputs. And since there are 4 outputs, there will be 2 selection lines. For different combination of these selection lines, different output lines will be selected. Now, this is the logic symbol for demultiplexer, 1 to 4 demultiplexer, 1 data input, 4 data outputs. And since there are 4 data outputs, that is 2 raised to power 2. So there will be 2 selection lines, S1 and S0. Now, this is the truth table of 1 to 4 demultiplexer. This is the data input, which is defined as D in all the cases. 2 selection line. Now say if selection lines both are 0, then in that case, Y0 output will be selected and the input D will be transmitted over that output line. Now for 0-1 combination, the input will be transmitted over Y1 output line. For 1-0, the input D will be transmitted over Y2 output line, and for 1-1, the input D will be transmitted over Y3 output line. Now, what are the applications of multiplexer and demultiplexer? Communication system enables communication like transmission system and communication network. The efficiency of the communication system can be increased using multiplexer because multiplexer allows the process of transmitting different type of data such as audio, video at the same time using a single transmission line. Similarly, multiplexer is used in computer memory to keep up a vast amount of memory in the computers and to decrease the number of copper lines necessary to connect the memory to other parts of the computer. Now for demultiplexer, demultiplexer receives the output signals of the multiplexer and converts them back to the original form of the data. The multiplexer and demultiplexer work together to carry out the process of transmission and reception of the data in the communication system. Thank you. This is all for today's lecture.